Okay, let's start. So this is where is my okay. This is the AI presentation. I think I have to switch it. Okay. So I guess you have heard about this, right? Some of you may have used ChatGPT, and then about 2 weeks ago came DeepSeek. Suddenly there was DeepSeek, and people got confused because ChatGPT was so good, and it was created by OpenAI. The thing about AI, OpenAI, is that when they created this ChatGPT, they said that they need billion of US dollars. I think about 15 or 18 billion US of dollars to create this ChatGPT. And then 2 weeks ago, bunch of engineers from China created DeepSeek, and they launched it to the world. And they said, we use like one I don't know 1% of what OpenAI created ChatGPT, and there was a big chaos. How could they started this DeepSeek with less money, less resources, and it is actually better than ChatGPT, and it is also open source. So people were furious. Many things happen. First of all many or not all many tech companies, the stock of tech companies such as Nvidia, Microsoft, all those, even TSMC, the stock prices, they went down. They took a dive. Why? Because people were surprised that they thought that most people think that when if you want to create an AI as good as ChatGPT, you need all the competing resources, and the only way to do it is if you have like chips from Nvidia, the GPU chips from Nvidia. Later on, we'll talk about this. Uh, so it's impossible to do it outside Taiwan. But DeepSeek proved otherwise, right? So people, he said, "Oh, maybe we don't need chips from Nvidia, or maybe we don't need that chips that money." So that was the big thing, and people said, "Oh, okay, maybe this is the real thing. Maybe ChatGPT was overpriced, and that's that." So basically, it was a big issue. To me, it was a good thing because to me, it's just a sign to prove that open source actually works. They create a better solution. And then a week after that, Quen appeared. And then, boom, again, it says that it is actually much better than DeepSeek. So, now we have three options instead of one. In fact, DeepSeek is free. Quen is free. ChatGPT, you have to pay if you want to get the professional, the commercial version out of it. For us this is a good thing because we have options that we can implement many of the things in our groups, our organization, our company, even our for ourselves. So this is a good thing for us, and this innovation actually open our eyes. Oh, okay, there's many possibilities, and you can do it with less money and less resources. So that's the key of this thing. Okay, so wait. Okay, now uh, I talked earlier, maybe in the beginning of the class. There are emerging technologies, um, and number one here is artificial intelligence. This is actually by accident. It's not listed as the importance of these technologies, but it's just listed as it is. The first one is AI, and then later on, maybe we'll talk more about cybersecurity and blockchain in future classes. Okay, so but anyway, AI has created disruption. Many of these emerging technologies, they may emerge and then die, but AI actually created a kind of big debates these days. Now, let's start with AI, artificial intelligence. What is intelligence? Now, when people talk about intelligence, in the old days, people are thinking, oh, okay, maybe if we talked about intelligence, is the smartness of a person. It has to be smart. What do you mean by smart? Well, if you are good in playing chess, then you are smart. At that time, the kind of the benchmark of being intelligent is if you know mathematics, and you know how to play chess, one of them. So this is an example of what they call a mechanical turk. A long time ago, people created a machine, kind of people obsessed with a machine. How do we create a machine that can play chess? So you want to have a machine that can play chess. So this was the result of that. They created a machine that actually played chess, but people did not realize that instead of like a real machine, inside this box is actually there's a small person playing chess. So the machine itself looks like a playing chess. So you're playing against this machine, but you're not actually playing against the machines. You're playing against this small person. But it was not proven, this mechanical turk, that this is actually there's a person inside. The I think the proof of this mechanical turk got burned down in one of the museums long time ago, and people think that, oh, okay, so mechanical turk is actually not the real thing. That's actually somebody inside, like a box. There was a joke in Indonesia a long time ago that we created like the smartest or the fastest, the most efficient washing machine. It takes only 5 watts, and it can do all your laundry. So you give all the laundry into this box, and then it will do the laundry. But apparently inside the box there is Insignor Jono was working very hard, doing all the laundry inside this box. So that was a joke. Anyway, but we were obsessed with this intelligence, which uh, maybe it's there, maybe it's real, but we still don't know. And then a few years later, when computer was around, people were created like this is the first chatbot. This is called Eliza, um, and this was created in 1966. I bet most of you have not born yet. Maybe your parents even was very small child. This is 66. Remember, a long time ago when computers were basically mainframe. So this is kind of the grandmother of the first chatbot. When I learned to program long time ago in 1980 or 1981, this is the first program that I actually retyped. I retyped the whole program. It creates the kind of behavioral like you're talking to a machine. So, for example, this is a session of Eliza. Eliza said, "Is something troubling you?" And then you type in, "Men are all alike." And then the Eliza will say, "What is the connection? Do you suppose?" And then you type in again, right? So it looks smart, but the answers are already written in Eliza. All he has to do is just basically select which answer is the most appropriate to answer your questions or your answers. So that's basically it's already hard coded inside the program. Nothing new. It gives you an impression that it is smart, but it is not actually. So this is kind of the old chatbot AI thing. Okay. Now these days, people are. I love movies, so that's why I love books. I love movies, and you've seen all these movies. Remember the homework that I gave you again about movie and all these movies. These years, you're going to see more AI kind of movies. Um, this Al Pacino movie is actually pretty good. Basically, Al Pacino found a machine that can create. So Al Pacino is a director of a movie, right? But he lost his actress, but he found a computer that can generate like an actress, right? So he created movies based on this machine, and nobody knew that the actress did not exist. It's just a machine, right? So they created that's the whole story. I don't want to create spoilers. The same thing with Will Smith in iRobot. This is actually an adaptation of Isaac Asimov, right? iRobot books. Okay. Anyway, you'll see more of this in the future. I'm going to skip this, but basically, we'll talk about generative AI later on. AI, there are two things. One is discriminative, meaning AI that can discriminate between objects, and now AI that can quote unquote generate objects. But we'll see. These days, people are talking about Gen AI, but we'll see the basic of AI first before we go into this. So you can like have these images, music, and so on. I thought long time ago that AI will not be able to create something that is creative, but now it's possible. Usually, when I look into AI generated images, I look at their fingers. Usually, their fingers, you have more than 5 fingers in AI. Anyway, now let's talk about the history of AI. The terminology of AI was coined by John McCarthy. This is John McCarthy in 1956. There was a gathering of computer science expert professors. They gathered, and then John McCarthy said, in the future there's going to be artificial intelligence, and artificial intelligence, basically, there are machines that can perform tasks that are characteristic of human intelligence. So the definition is very broad. Anything that can perform tasks that, yeah, similar to human, it's called AI. Okay? So this was the definition a long time ago. And then let's refine this definition again. Today, the state of the art of AI is still in what we call a narrow AI. Narrow AI is an AI that can do specific tasks. We don't have general AI yet. Just like this Arnold Schwarzenegger, right, in the Terminator movie. We still don't have that one yet, an AI that can do all kinds of things. Your AI can do one thing. For example, it will be able to recognize images, the difference between a person, and so on and so forth. Or it can recognize defects in your plan, manufacturing plan, or it can generate whatever, like song for you. But it cannot do all kinds of things, like for example doing your laundry, washing your car. AI still cannot do that, so we still do not have general AI yet. AI is not alive yet, as AI is not awake yet. Is People call it probably what we call it in Indonesia, we call it kesadaran, right? Awareness. We still don't have that one yet. AI is definitely smarter than us in terms of the IQ, but it's not the thing. The only thing. For example, we know that motorcycle or cars can run faster than us, right? We don't have to compete with cars. We can run, but will never be able to beat motorcycle, for example, right? Motorcycle can run faster than us. So that's the thing. We won't be able to beat AI or machine if we want to do some kind of calculation, for example. If I ask you to multiply two numbers, for example, calculators are better in doing that, right? If I ask you to multiply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, oh sorry, at 9 multiplied with 7 7 7 7 7 7, we got confused, but calculators or computers can do it faster, but that's fine. But other things like having empathy, having a spiritual discussion, AI still cannot do that. So we have other equations or other what we call characteristic that may not be able uh, imitated by machines. Okay, we'll talk about this later, maybe in a discussion. So now let's talk about the history. Remember, AI was coined by McCarthy in the 56, so it was somewhere around this time. So the terminology, it's AI. It cover everything. But around that time, computation was limited. There were only mainframes. Maybe there were five mainframes. That's it. Nothing else. So AI was limited at that time, and it could not solve a problem, a simple problem. We call it an XOR problem. It's basically, if you have like a chess, something like that, you cannot separate these two linearly separable objects using AI. A long time ago, this cannot be done. So that's why people said, AI is a fraud. AI is just all the computer scientists, mathematicians, or but it's basically a fake. So AI at that time, it was a hype, and then AI died. Maybe around 70s, AI died. We call it AI winter. All the research was canceled, and even some of the researchers actually went to suicide because of this, because they said, "Oh, okay, you are fraud. AI, am nothing more." Okay. In the 80s, AI came back alive again. Remember that personal computers were developed around 1975. So at that time, there were Apple PCs, IBM PC, XT, and so on and so forth. and then the internet was also developed or actually being used around that time. So AI arrived again at that time, and they call it at that time machine learning, or at that time they call it artificial neural network. We'll talk more about that. So this is when I learned about AI. I took a course on AI in 1986 or 87, a long time ago. So AI at that time again was very useful. It can be used to detect whether you have a spam email or not, and then that's it. Again, AI died because that's the only thing that AI is was good for. And then in 2010, again, there was a new innovation. George Hinton and friends, they can use computer vision to distinguish between a cat and a dog, for example. So AI gained popularity again, and then people call it deep learning. Later on, we'll talk more the differences between machine learning and deep learning. But if you can think about it, all these are AI. Okay, artificial intelligence, machine learning, deep learning. They're all under one category, big category called AI. The other thing, if you look into the timeline, it took about 30 years. Like the first chapter, it took 30 years. And then the second chapter, it took 30 years. So I'm thinking maybe in the future, it's going to be the same again. In 2040, AI is going to go down or die again. Winter, there's going to be AI winter again, maybe around 2040. And Indonesia Emas, Golden Indonesia is 2045, right? Somewhere around here, right? Maybe at that time we have a new AI based on quantum computing, maybe. But if you think about it, then AI has its ups and downs. So AI this year is still at the top, like the hype or the euphoria of the AI. Even Hinton and can't remember the other person name. They got like a Nobel Prize because of this, right? The improvement of AI in this. Okay, so AI, machine learning, deep learning, they're all fall under one category, AI. Okay, so I'm going to skip this one. Some of the slides I'm going to give you the slides, but some of the slides are still in Bahasa Indonesia. I'm going to skip this one. Okay, now there's a good book called The Master Algorithm. By Pedro Domingos. This is kind of an extensive book. It's a bit heavy, the reading, but I know some of the leaders in many countries, the big boss, even president, even prime minister, they read this book to understand, well, what's going on with AI. So apparently there are 5 tribes of AI. In Bahasa Indonesia, there are 5 mazhab. There are 5 tribes. So if you think about it, there are 5 tribes. I learned by accident. I learned all of these tribes. The one that is popular these days is called connectionist. So when we talk about AI today, is an AI that is a connectionist point of view. The origin of this idea is from neuroscience. Okay, so the AI of this one is from neuroscience. So let's go back to this. In the 80s, we were confused because we still don't understand AI. We did not understand AI. How can we distinguish, for example, if I give you a problem, write me a code to distinguish between a cat and a dog from a picture. So if I have a picture of a cat and I have a picture of a dog, how do you know which one is cat, which one is a dog? So you have to write a code. Now, what is the difference between a cat and a dog from a picture point of view, not from the sound? Do you have any idea what's the difference? Any opinion? Answer?
Uh,
Differences
the
in physical appearance, but
Yeah.
yeah,
Well,
between
what
a
is?
dog and a cat.
What is the a dog and a cat? What's the difference between a dog and a cat?
Cats are smaller and they have pointy ears.
But if you see Chihuahua, right, the small dog, right, it's very small, like
True, true,
this
but
big. So,
they don't have pointy ears.
some of the dogs they have pointy ears also. Some of the
How
cats
about
they have kind of flapping
uh,
also.
Their hidung is different too. The cat's
yeah,
hidung
the
is
nose.
closer.
Yeah,
Yeah,
and
but how
also
can we
cats have
divide? What is the difference
Whiskers.
between the hidung of the cat from like, is it smaller, bigger, red?
Smaller. It's more
Smaller.
you say deep set into the face.
Right? So it is difficult, right? If I give you a picture and I ask you to write a code, then you may guess that's probably the feature, but it may be true. It's not. But if you give a picture to like a 6 years old children or kid, and then you can ask what is this, and the kid will say this is a cat, this is a dog, right away. How does it work? So that's why we don't understand how is that a program running in your head, in our head. What's the difference? So because we don't know, let's talk to. The idea is let's talk to a neuroscience. Let's talk to a neuroscience. This is from computer science or computer engineering point of view. I don't understand how our brains work, but our brains kind of work because it can distinguish between a cat and dog right away. How does it work? I don't know. Okay, let's open our head. So we talked to neuroscience scientists, and they said, okay. Anyway, so this is our head. Hang on a second. Let me just get my tablet. So if we open our brain, this is the what our brain looks like. Let me just get my. Okay, so my our brain looks like this. Our brain has a collection of what we call neurons. So these circles, this is what they call neurons. Let me just get my pen. Okay, so these are neurons. So this circle is what we call a neuron. In our head, we have billions of neurons. So if we have billions of neurons, and they're connected to each other, just like in this picture. In this picture, the connection, the neurons is probably only hundreds, but the connection is very sparse. But we have a very dense connection in our brain. That's why if our head got hit, or we hit our head, right, knock, and then maybe three of the neurons died, I don't know. That is fine because we still have billions of neurons. If our head consists only 100 neurons and three died, it's a big thing, right? But that's why we have billions of neurons. But how does it work? Okay, let's move on and to look into our brain. What is this small neuron? So biologically, neuron is something like this. Okay, something like this. So there is the central one, the central one, the nucleus of the neuron. This is the kind of the main neuron, the central of the neuron, and it has many connection as input. They call it dendrites. Maybe this is a connection, that connection, that connection. So these are the inputs, and they're connected to other neurons. Maybe this is another neuron connected to that one. This is another neuron connected to that one, right? So basically, it has many inputs, and it has one output, one axon. It has one output, and this output may be connected to other neuron. So we can have like, where's my, okay, maybe it is connected to that neuron, maybe it is connected to that neuron again, maybe there's another neuron connected to that one. So basically the connection is kind of complicated, but the idea is the physical is like this. So from this other neuron, basically what happened is we have electrical pulses, like pulses. So it kind of pulses, and then it sends the data or the pulses, right? I don't know, pulses, maybe like that, into your neuron, and it will combine everything and then send it outside. So a model. Let me just remove this. The model of that one is actually like this. Okay, a model, a simplified model. We have something here. We have many inputs. Maybe input number one, input number two, number three, and so on and so forth. And then we do something here, and then we produce output. What does it do there? Oh, what we do is here is actually a summation. So we actually the sum. So we just add, just sum or add the input. So we add one, two, three. We add and then send them out. So that's the whole idea. So in more compact version. So this is what we have. So this is one neuron. Okay, this is a neuron. Okay, a neuron. It has many inputs. Okay, has many input. This is input number one, number two, number three, number four, and so on, number n. Okay, and it has one output. Okay, it has one output here. Okay, right. Now, like I said earlier, we just add x1 plus x2 plus x3, but it's not interesting. What we are want to do is we want to have some kind of weight. For example, x1 is multiplied with some kind of weight number one, and then add them with the rest of the input. So this one is x1 multiplied with weight number one. This one is x2 multiplied with weight number two. This one is x3 multiplied with weight number three, and so on. Now the weight itself is the number is between 0 to 1. Okay. So for example, if this input number one is very important to this neuron, this is from the neighboring neuron, right? Maybe the weight is maybe is 0.9 maybe. Okay. The weight is 0.9. Maybe neuron number two, it's not that important. So maybe the weight here is 0.001, maybe. Maybe neuron T is somewhat important. So maybe this one is 0.3, for example, or, So basically, you sum everything. So this is the kind of the formula. It's just an addition of all the input multiply by the weight. So x1 multiply one x1. So this is the z here is that one. Okay, that's it. So we have billions of neuron, and the neuron does only one thing, addition, and then that's it. This add. Okay. Now if you add these things, then the number can be big, right? Can be big. Like for example, if you have say you have like 1,000 inputs instead of only 10, 1,000 inputs, right? So if you add them up, maybe the number can be big. So that's why they have this is what we call activation function, and this is limiting the output. For example, let's say we have the sigmoid function. You don't have to understand this, like the mathematical, but basically, this is limiting the output. So if you have, let me just give you an example like this. Okay. So sorry, this on the flat. So if your input is zero, the output, this is input, this is output. If the input is zero, the output is zero. If your input is 0 point something, the input of zero something. But if your input is, say, for example, one, the output is almost one. If your input is two, this one is still one because you're limiting basically here. So this is a way to limit the output. So it's not going to overload the next neuron because it's going to be connected to another neuron, right? So the output is limited here, okay? Because we may have big kind of thing. Yes, Florida.
Uh, Thank you, Pat, for the explanation. I was just wondering, right, since you mentioned that AI is basically inspired by how our neurons work.
Mm-hmm.
And I'm not an expert on this, but I think neurons also control our emotions in some way.
Mm-hmm. Mm-hmm.
Do you think in the future AI could eventually basically recognize and express emotions like us humans? Or what do you think the limit that stops AI from doing that nowadays?
Okay. So in the future, so AI can recognize our facial expression, maybe, oh, you're sad or you're crying, but AI cannot express themselves. It doesn't have the ability to express themselves. Basically, it is only one kind of axis, intellectual. That's it. It doesn't have all, like if you ask an AI, can you solve this problem? And AI will say, I don't want to do it right now. I'm kind of in a bad mood. I don't want to do it. I'm tired. No, AI will not do that, but human can do that. So that's why AI cannot do that. What we call singularity. AI will won't be like human. Actually, I wrote a book with some friends, and the title of the book is Dapatkah Silicon Menangis? Can silicon cry? And our conclusion is it cannot. It can jadi AI can have like a water from quote unquote eyes, but they're not crying. They're not crying, right? They don't have heart. But they can mimic the behavior, but they don't have empathy. They can think like that. So if we are well, if we created an AI machine based on logic, on computers, on logic, then it can only obey mathematical logic. And if you have mathematical logic, then you cannot express emotion in mathematical logic. It's just impossible. Unless in the future we're building a computer which is not based on logic, which is based not from silicon, maybe it is based on carbon, on bio, then it is possible. But for now, mathematically is just impossible. So in the future, we won't be have we won't have like an AI just like human in terms of the emotion, and which is a good thing, which is a good thing in my opinion, because you don't want to tell your washing machine you're doing washing machine, you want to do your laundry, right? You put your dirty clothes into a washing machine, and then the washing machine said, I'm tired, I don't want to do it, I'll do it tomorrow. You're going to kick your washing machine. You do it now. You're a machine. You don't have feelings, right? So yeah, it won't be possible. That's my opinion and opinion of many others researchers. But there is a newer book by Kurzweil. A long time ago, he wrote a book. They call it Singularity is Near, and then he updated the book, and the book is called Singularity is Nearer. So Kurzweil said, maybe we can see the general AI in our lifetime. Maybe 10 years, 20 years, 40 years, 60 years, I don't know, 100 years from now. But he said it is possible we can have like a general AI. But from our point of view, mathematically, not possible yet, unless proven otherwise, it's not possible. So that's the case already. It will not create emotion. Okay.
Understood. Thank you, Pak.
Okay. Yes. Otherwise.
Thank you, Pak Budi. So maybe I just want to share, when you were talking about the neuron, I think it's like a comparing a neuron in our brain. It's like
Yeah.
comparing a toy car to a real sports car. Like, AI is fast at specific tasks, like, like
Mm.
data crunching, but our brain is flexible, creative, and can learn. And
Mm.
be honest, I want to say that sometimes I do curhat to AI
Mm. Mm.
because yeah, maybe AI might not have feelings, but
Mm.
it's designed to understand patterns in human behavior and language. That's why it can give response that feeling comforting. To be honest, it picks up on the words tone and
Mm.
context unit. Like it reflects back clarity, structure, and sometimes the exact words I didn't know I
Mm.
needed. Even without emotions,
Mm.
I think AI can still be a solid listener for me. No judgment, just there to help me
Mm.
process. Because maybe not everyone can talk to their parents or their family.
Mm.
Like maybe
Mm.
just isang want to curhat in AI.
Yeah.
I think it's really
Yeah.
good. But and
Yeah.
I
Yeah. But
do
later on, we'll see that AI works
that.
based on data set or training set,
Mm,
patterns that it was trained on. So if it is trained on certain things, then it has certain bias to certain things. So
mm,
that's the bad thing about AI. AI it's not the real thing. It can have bias. It can give you wrong answers depending
mm,
on the training set. Later on, I'll show you an AI. These days, the AI are good because they have very big data sets, but they have some limitations. Still have limitation. So that's because it's just because I'll explain later on about data set. Why there's a limit in the way AI is presented right now. It depends on their data set. Okay. Okay. And then later on we'll say, oh, okay, the data set is big, but it is limited. It's still limited. Still limited. And our brains is actually much better than that.
yeah, that's still
Okay.
our human superpower.
Yeah, but in terms of reasoning or IQ, Actually, AI machines actually right now 100 times better than us. 100 times, or maybe in the future it's going to be like 1,000 times better than us. But in my opinion, there's no need for us to compete with AI. Just like there's no need for us to compete with calculator. Why do we want to compete with calculator? Or why do you have to compete with motorcycles or
Agree.
trucks, for example, right? Let's just ride a car or motorcycle, right? We don't have to compete with them. But motorcycle cannot wash our laundry, for example. If they can, maybe it's better.
Yeah, just use it.
Yeah. Yes. Next question, and then we'll go back. Okay. Okay. Yes. Katlia.
I actually want to ask about how training AI works because
Okay.
currently
Okay.
I'm supervising a project where we are making a website with a chatbot that is
Okay.
integrated with AI. It's
Okay.
actually used for English education, sir, and we would
Okay.
like for the users to interact with their AI and receive feedbacks on
Okay.
their English proficiency level. So
Hmm. Hmm.
I've been planning to feed certain English materials into it, but
Hmm.
I'm still not very sure how much data it needs for it to
Okay.
be interactive with the user. So if you have
Hmm.
some input on that, probably it would help a lot. Thank you.
Okay. Remind me later on, almost at the end of the class, RAG about RAG, RAG. Okay. Remind me about RAG later on. Okay. Okay. Write it down, RAG, because right now I'm going to teach you how AI learns, and then later on, how AI learns based on other, experiences. Okay. So you don't have to learn from scratch. Okay. Remind me about that later on, because I'm going to tell you about how AI learns right now. Okay, but specific for you that and to answer your question in terms of your project, you can use RAG. We call it RAG. Okay, okay, but okay, remind me. Okay, at the end because for that specific question. Now, this is how our brain works, right? But how do we learn? What do you mean by learn? The learning is actually setting up this weight. Okay, how do we learn that? Oh, okay. Anyway, let's go back to that learning part. But this neuron, remember, we have this neuron, right? But we can organize the neuron like this. So remember, our head, we have billions of neuron. But think about it. See, this is an arrangement of, I don't know how many neurons. One, two, three, four, five, six, seven, eight, nine. Okay, so now we have nine neurons. And how do we arrange them? This is the architecture of a neuron. Well, we can do it like this. Remember, our brain, there are billions. Oh, this is just an example of nine neurons. Because our brain is very complicated and it's difficult for us to understand, let's simplify. This is for us, human, to simplify the idea. What if we create layers of the neuron? Let's just create layers. Like this is the first layer, this is second layer, this is third layer. We can do like this, right? Oh, maybe we can make it more complicated. We can have the first layer, okay, second layer, third layer, fourth layer. Okay, so we have more neurons this day. How about if we more layers? We can have more layers like this, right? We have first layer, second layer, third layer, fourth layer, fifth layer, right? For face detection and recognition that you have in your phone, for example, there are probably at least 25 layers. And for us, we have like our system, we have like 75 layers of this. You can imagine like 75 layers of this. So the number of neurons is probably big. But you can imagine, if I have like, I don't know, maybe 10,000 neurons. 10,000 neurons is nothing compared to our brain, right? Billions of neurons. So, but this is how it works. Okay. So the number of neurons you can see, I don't know how many neurons here, but you can see like the weights. It's getting complicated, right? Now this is what we learn, or what we want to learn. Okay. How do we learn this? Oh, okay. Now let's see. We have a combination of neurons, something like this. Let's just move this. Okay. Suppose we want to have a system that can recognize handwritten numbers. Like for example, if I type in this and it will recognize that's two. If I want to type write this and it says seven. How does it work? Okay, first, let's train a neural network. Suppose we pick the architecture is something like this. We have, I don't know, this is the first layer, this is second layer, third layer, fourth layer, fifth layer, sixth layer. So maybe we'll have like a six-layer neural networks or arrangements. By the way, we're going to write this code maybe 2 weeks from now. We're going to code this. Don't worry, you're going to code like a low-level neural networks in 2 weeks from now. Now, suppose the image, like you type in or you write the image. So maybe this one is 32 pixels, okay, by 32 pixels. So you have 32 pixel and then 32 pixels, right? To the right side. So the number of pixel here is, I don't know, let's see, 32 multiplied by 32. Calculator. Can you answer this one quickly? My head is kind of exploding. Okay, let's see. Let's do it the old way. 4,
1024.
6, yeah, 9. Oh, okay. 24, right? Okay. So we have 1024 pixels here. So to do that, I need to have this pixels entered into the system. So I have the first layer is I have 1024 neurons. So each neurons is connected to this one. So this is the first neuron, second neuron connected, the second pixel, third pixel, Basically the first layer we already have like 1024 neurons. Okay. And then from this 1024 neurons, we're going to connect it to a smaller kind of neurons, sets of neurons, like this, like this, like this, like this. Okay. So that's the architecture first. Now, let's train our system. Because we still have like a zero knowledge. When we put, say, this is an example, put number 3, and then this system or your AI will say, oh, this is number 7. Wrong. This is supposed number 3. Okay, by the way, this is there are 10 digits, right? Here we have 10 digits, and it actually will say which one is the number. Okay, so if you put 3 and then it will say, okay, 7. We know that it is wrong. Okay, this is wrong. So you penalize the system because this is wrong. You have to propagate back the errors to the original. Okay, because this one is 7. Let's reduce the connection. Okay, reduce the connection of 7 to the back. Reduce the connection of this. Reduce the weight. Reduce the weight. Okay. For number 3, this one is number 3. The correct answer. Okay, increase the weight. Increase the weight. Increase the weight. Increase the weight. Okay. So that's this is the first data set. Put 3. Okay, and then you put say for example number 2, and then the system will say that's 8. Wrong. Okay, again you propagate the error again, and then you enter again maybe number 7, and it says 5. Wrong. You propagate the error again. You put 9, and then it says 9. Oh, okay, you're correct. No need to propagate error. Put again 4, and it says 7. Wrong. You propagate again. So basically you do this many times. Put again number 9 again. This time it says 7. Oh, this is still wrong. Okay, propagate again. So what you do, you're propagating error to the back. That's the algorithm. It's called back propagation. So the propagation is propagation. But the whole idea is to propagate the error back to the input so that it will settle the weight here. And then you try again. 5. Okay, says 2. Wrong. 1. 1. Correct. You do this over and over again millions times until it is basically almost right. You give it number 7 and it says 7. Give it number 5, it says 5. Get number 8 and it says 8. And give it number 9, it says, oh, sorry. 9, it says number 8. Oh, okay, wrong. So basically, maybe from 1,000 experiments or 10,000 experiments, maybe you have, I don't know, 100 wrong. So 100 of 1,000. So this is like a 1% error. At least the accuracy is 99% and you're happy. Oh, okay, I'm happy. From 10,000, I've got like maybe 10 wrong or 100 wrong. So you're already FE. So you do this over and over again. That's what we call learning. Learning. So this is what we call a data set. So we train it with many data set. We'll do it over and over and over and again. So because we have data set, we do it this and it may take, for this one may take, I don't know, most 1 hour, 2 hours, 7 hours, until the kind of the weight here settles down. Now, you do this in terms of character recognition. This is very simple problem, and maybe it will work for like an hour or 15 minutes or so. But if you have like an object detection, where you can distinguish if it a cat or a dog, maybe it takes more than that. Maybe it takes 3 days to do that. Maybe you can learn it 3 days. To detect the human, for example, Budi Raharjo or Helmi or whatever, right? Maybe it takes 21 days, maybe 20 days. So that's why you have to do this over and over again automatically. You run it this over and over again. Now, to do that, remember you have to put this and then calculate back. The algorithm itself is something like this. This is like for math. This is not a math class. We don't need to worry about this, but there is an algorithm to do that, right? Anyway, so that's the algorithm. Now, to do that, you need a very good CPU to do that. But apparently, if you do this in CPU, it's not very efficient. This is good if you are using graphical processing unit. So this is the CPU, like if you have i3, i5, or i7, like the general purpose processor, it is good to do all calculation, but they're not good in doing all kinds of in learning like this, the algorithm. So if you are using CPU, for example, it takes 21 days. But if you are using graphical processing unit, maybe from 21 days, it is reduced to 1 hour. So the reduction is very, very significant. Okay. Maybe if you are using better GPU, then maybe it takes only 10 minutes. Okay. Now, the GPU these days, the company that makes GPU, the most popular one is NVIDIA. So that's why NVIDIA, the stocks are up there. Some even at one point, NVIDIA is the stock is the market capitalization is bigger than Microsoft at one point, because they're selling this GPU. And GPU usually it is used by gamers, right? Gamers, and if you have gamers, you buy NVIDIA RTX whatever, right? You buy GPU. But fortunately, unfortunately, GPU is also good in calculating hash function, which is used by blockchain or Bitcoin, blockchain or the Bitcoin or cryptocurrency. GPU is also good for that, and GPU also needed for AI. So that's why people are looking for GPUs. So that's why if Nvidia, if they create a chip, people will buy it basically, because everybody is looking for GPU. Now today, some of these companies created what they call NPU, basically neural processing unit, which is specific for this one. But GPU is still the thing these days. So that's why if you want to do this, you need GPUs, very very expensive GPUs. Right now, I think the latest one, the bigger one, I think Nvidia sells the latest one. I can't remember. I think one GPU is about 100,000. Ini berapa miliar ini ya? Okay, so you can see, like
1.5, Pak. 1.5 million.
1 miliar ya. Ini
Yeah.
RP 1.5 miliar. So right now, even our university, we only have one machine with, I can't remember. So we need more GPU. So that's why GPU is very 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 important these days. That's why people are buying Nvidia. That's why DeepSeek was surprising many people, because they thought, hey, how do you get GPU? I thought Chinese companies or research group, they're banned by US, right? You cannot buy Nvidia chips, but how come you can do computing much better than OpenAI. So that was the question, big question. Oh, how did you get NVIDIA GPU, or did you create your own GPU, and so on and so forth. So that's one. So this is what we call learning. This is the original learning in terms of neural network. So going back to your question, Katlia, later on we'll see that you need to have data set here. Okay. Again, also this one answering the question from Edelweiss. So this is an example of handwritten recognition. How about cats and dogs? The same thing. We have pictures of cats. Okay, so we have a picture of cat, and then we have a picture of dogs. Right? I don't know how to drive a dog. Dog, right? For example, right? We have picture cats and dogs. We have to train it. Okay, this is the cat and dog and cat and dog and cat and dog. So inside this machine, it is basically trying to learn the weights so it can understand cats and dogs. Philosophically, what we are trying to do is this. The system that we are using, it's basically creating this is an example, right? For example, we want to distinguish between cat and dog. So our AI system is basically creating this line to separate between cats and dogs. For example, let's distinguish between a cat and dog based on the size, domestication, and so on. So the first set, we have two pictures, a cat and a dog. Okay, so this is a dog, this is a cat. So basically, there is a line that can separate that cat and dogs, right? So this is it. And then we have another example of dog. Okay, this is an example of dog. Okay, smaller than that one. Oh, okay, put it here. Oh, okay, the line actually changing, change into this one. Kind of the slope going down. And then we have also two examples, smaller dog and smaller cat. Okay, the line, keeps doing like that. And then we have another example, smaller dog. Even the dog is actually smaller compared to the cat, like this, maybe a Chihuahua. Okay. So again, the line is changing. So you do this over and over and over again. You do it, like many, many times. And then basically you have a system of a system that can distinguish between a cat and a dog. So if you give an AI system, this AI system, a picture of a cat, and it will say, that's a cat. If you give it a picture of a dog, that's a dog. Okay. So this is the whole idea. Now, the question is, if I give it a picture of a horse, what would it say? What do you think? I give it a picture of a horse. What is the answer? Is it a cat or a dog?
I think the system would recognize the horse as a dog due
Probably
to
right.
its big size. Yeah.
Yeah, probably they say, oh, okay, this is a dog. Well, why can't it say it's a horse? Because it is not trained to recognize a horse. So, Pa, if I want to have a system that can understand cats, dogs, and horses, how do I do? Well, let's train them with pictures of horses. So you have pictures of cats, right? And then you have pictures of dogs, and then you have pictures of horses. Okay. But the line is not going to be two-dimensional, probably three-dimensional. But you can view it something like this, like three-dimensional of dogs. So you train them and basically you get, oh, okay, now the system can understand cats, dogs, and horse. What if I have a picture of, say, an elephant? Well, it doesn't know elephant. Okay, let's train again with a picture of elephant. No, we have more again, elephant. Okay, so now it recognizes for objects, or we call it class. So this is the classes. We have 1, 2, 3, 4, 4 classes. What if I give it a picture of a fish and can understand fish? That's a fish. It does not understand this, but it will pick one of them. Says, okay, maybe it is cat because it's small. Maybe. So we have again. Let's try it. Okay, three seats again with fish and so on and so forth. So to answer the question, handle-wise, if you want to train the system that can understand things, you have to train it with all kind of classes. So that's why it can recognize you. In the old days, when Hinton and friends started again the AI revolution, they are doing computer vision. So now the problem with computer vision is again the classes. How do we recognize this? Uh, do you have like a pictures all kind of objects? Now that's a bit difficult because you have to have a list of objects in the world. Fortunately, there's a group called ImageNet. ImageNet has a collection of millions of pictures labeled. So if there's a picture of bicycle, it says bicycle. Okay. The picture of car, car. A picture of a dog, dog. A picture of guitar, guitar. A picture of glasses, glasses. So it has like all kinds of images, millions of images, so that you can train them. You can train your AI system using those millions of objects. Okay. So computer vision. The same thing. When I started my company, when we started earlier, we started using what we call a automatic license plate recognition, ALPR. So the ALPR, we want to have like a license plate. Say for example, I have D123 XYZ, right? So I have to understand, okay, this is a D. So I have people actually to collect this. I was looking at that time. This one 7 years ago. I was looking for a collection of license plate, Indonesian license plate. There was no database of Indonesian license plate. So I had to take pictures. It took me 3 months. Every day I went out and actually took pictures of cars, license plate every day. I went out and took pictures, just like a crazy person, taking a picture of a license plate. I got, I don't know, thousands of images. And then based on that, I need somebody to actually cut it. So this one, maybe this D, let's just cut it. And then we call it, this one is D.jpg, for example. And then this one is 1.jpg and so on. 2. So I have to have this. Now to make it work, for each class says I need to have like A, I have to have 10,000 images of A, B 10,000 images of B, C 10,000 images of C, and so on until Z. And then the same thing for 1, 2, 3 until 0, 1, 2, 3 until 9. I have to have 10,000. So you can imagine I have to have many this. There were, I can't remember, millions of images. So it took me quite a while to do this. And I had to pay somebody to do this, to actually create these images. And for me, it took me about, I can't remember, 5-6 months to get the data set. And it actually cost me about 75 million rupiah. Mahal ya, 75 juta to create this data set. So the data set is very expensive. Because at that time, nobody has a collection of license plate. So we had a collection of license plate data set. And if somebody asks me, Pak Budi, where is your data set? I can say to them, oh, I collected data set. Can you sell it to me? I cannot. Because the way I took the data set, right? I went out and took pictures of cars. The car owner, they say, the car owner doesn't know that, I actually took their picture. So including to regulation, this is kind of consider what about privacy, right? So what I do is my apa ya, my pendekatan, my way of doing this is lebih baik minta maaf daripada minta izin. It's better for me to ask forgiveness than asking permission. So if somebody got mad at me, why is my license plate in your direct database, Pak Budi? And I said, sorry, let me delete your license plate. So I cannot open my license plate database because legally I have no idea the legal status of my database. Although I'm not selling that database, but the way I took the database, I didn't get permission to that. So AI, to some degree, has problem with privacy. The same thing, we have face detection and recognition. I have face detection and recognition. How do I get the database of face? I ask students. Maybe next week or 2 weeks from now, I'm going to use a system like face detection and recognition as an attendance list in our class. You have to register that. Setor muka. So that's what I do. I collect images of my student pictures because there is no database of Indonesian pictures. So this is a problem. The same thing when we do, say, in healthcare. Okay, healthcare. So let's talk about COVID-19, for example, COVID-19, right? So what we do is we take X-ray picture of the patient. So I need the patient like 10,000 people X-ray picture of a person with COVID, and then I need also 10,000 X-ray pictures of person who do not have COVID. How do I get that? I don't get permission. So that's a problem. If I don't get data set, I cannot create my AI. How do I do that? I don't have the data set. So that's the problem. That is why AI is slow in the US because lots of privacy, and AI is faster in China because there's no problem in privacy. So that's why AI in China is going to win pretty big compared to the US because of data set. As simple as that data set. So this is images, right? The same thing happening also in terms of text. If we want to say a text, like for example, uh, say for example, saya pergi ke pasar. So there's a word saya, there's a pergi, there's a pasar. So you have a collection of those words, and it has to be entered in database. Saya, aku, I, gue, aing, all those words, right? We have to collect those. So that's why when we start English is the majority of research in terms of language. Originally, the database, the language itself is very limited, very small. So it was difficult when I started this one like 15 years ago. I wanted to create company, but it was difficult because there was no database of spoken word, of even text, like dictionary of bahasa Indonesia, saya, aku, dia, and so on, right? That's But today, because we can collect all of these texts that's why we call it large language model. So that's why we have all the words. We call it the token of the words. This is token. We have lots of tokens. So let me give you an example in text. Budi Rajo, I am a lecturer. Budi pergi ke, just like the completion in your cell phone. Budi Rajo pergi ke, what's the next word? Probably. What do you think? Budi Raharjo pergi ke apa lanjutannya? What's the next word? Budi Raharjo pergi ke? What do you think?
In my phone, when I type
Eh?
Raharjo pergi ke, there are three options. There are three: masjid, gereja, kamar.
There's no kampus.
Oh.
Budi Raharjo pergi ke kampus ya. Okay, so yeah, why? Because that's what the data set is trained on. So it is basically just like kucing pergi ke kucing pergi ke pasar. Maybe I don't know. But yeah, that is why now in terms of large language model, it can predict up to 1,000 characters. 1,000 words ke depannya. It can look up to say 1,000 these days. The large language model it can look up to. But when we use like a small language model a long time ago, we can only look up like 2 or 3 words. We can predict 2 or 3 words, but today we can predict like 1,000 word. So that's why large language model works because it can do that. Now we are trying to build the same thing again using the system, right? Okay. So that's how we learn. Okay. Now, let me just say, but the core of deep learning is only two. One is the architecture, and then the other one is the data set. What do you mean by architecture? So this is the architecture. The architecture is something like this. Okay. Remember when we have like this this right is this character recognition. This structure is something like this. So in terms of the architecture, the if you are talking about object recognition, this is what we call it. Usually we use the architecture is something like this. This is called convolution. This is convolution, or deep learning convolution. It looks something like this. Maybe the layers could be like 25 layers, 17 layers, 75 layers, what have you. So it is something like this. If we are talking about something that has language history, we usually, well, we started with this. Okay, LSTM, LSTM, long short term memory. So this is kind of the neurons, and the connection is similar to this. This is if you want to have a model. Maybe it's more complicated than that, right? But it is something like this. So there are many architectures to choose from. So that's why, in terms of creating a system, you need somebody to look into this. This is an engineer, right? Engineer problem. This is you need people who very understand the architecture of an AI system underneath. So this is the architecture. And then the second part is the data set, whatever you feed into the system. Now, for example, if I want to have like a system that can recognize my face and so on and so forth, I can train it using some kind of architecture. I don't know, maybe architecture. People are, usually you say YOLO, one of the architecture, right? You only look once. This is an architecture for image recognition. The YOLO is as some kind of connection things, but you have to train it with data set. Okay. Now, once you train it, it can understand. Maybe it can understand car, motorcycle, or whatever, right? So you can train it from scratch, but that's not what we do, because it's going to take years or months to do that. For example, if let me give you a rough estimation. A long time ago, when I trained myself using AWS, okay, so I have to train my system, and it takes 20 days to just one pass learning. And if I learn one on AWS, the cost is about, I can't remember, $10 to $12 per hour. So if you can do this 25 days, one day is 24 hours, okay? And then you multiply again with 10, for example. So this one is 48. Just one run, it's going to cost you about $5,000. Just one run. If you try to experiment this, right? So you end up with thousands of dollars. This is dollar, by the way. One pass is going to cost you. So if you try to experiment this and you're not happy with it, you are losing. For us, we lost like maybe one run, $5,000 for just one run, because it takes 21 days. Sorry, 20 days. That's why we don't build model from scratch. What we want when we call model, is this. Once we have the configuration and the weights already trained, right? This is what we call a model. Model is a combination of the architecture and the weights. We call it a model. So that's why we don't train model from scratch, because it is expensive. What we do, we take somebody else's model, which already trained, and then we train on top of it. So that's why people call it transfer learning. So you take model from somebody, okay? This is model, and then you add your own data set. So this is what they call transfer learning. Okay. So transfer learning is adding, this is existing model. So you look a model that is closer to what you need to solve the problem. So for example, somebody else already developed that kind of model to detect fraud, or you have model to, like you said, trying to check your English, for example. Get that model, okay? And then increase that model with our own data set. You train it again. So that's one way of doing it. You don't build from scratch, because it's just too much hassle. There's another way of doing it. We call it a RAG. RAG. Okay. Now, here's what I'm suggesting to you. Okay. So for example, we use ChatGPT. Okay. ChatGPT. ChatGPT already, or DeepSeek, or Qwen, whatever, right? They already train with many kind of languages. Languages. So you can think of ChatGPT as a person who understand English. This is your, in my bahasa Indonesia, this is guru bahasa. Guru bahasa Inggris or guru bahasa Indonesia. This is basically your language teacher. It can understand you. That's why Edelweiss is talking to the ChatGPT, because this is a person or a model that can understand language. You can talk to it or he or her or him, right? To talk to this. So you can talk to this, but ChatGPT can only answer whatever it is trained on. So, for example, ChatGPT, tell me about, I don't know, President of Indonesia, and it will tell you. But if you ask ChatGPT, tell me about the profit of my company, and then ChatGPT will say, I don't know. I am not trained to use data from your company. So that's why, oh, okay, if I want to use ChatGPT to understand my my company, but I don't want it to learn the data of my company because it's confidential. I don't want to give it to ChatGPT, right? So I don't want to train it using my personal data. So what we do is we build our own data set here, our own data set, right? This is our, say, for example, database of our revenue, company profile, or whatever, right? This is our own personal database. Sorry. So when I ask ChatGPT, and then I says ini, ChatGPT, please answer this question. But before you answer that question, please have a look at this database first. So that's what we do. This is retrieval augmented. So this is what we call RAG. There's a, but basically you have to get a model first, and then you use that model. Be that the model is ChatGPT, be that the model is Qwen, be the model is DeepSeek. Basically, you have a model. I hope that answer your question, Katrina. So you try to find what do you call right? Or if you want to get more info, you call it transfer learning, which basically add your data set to existing model, train it using existing model. So basically, you embed more into the existing model. Say, for example, if I'm in healthcare and somebody already developed a model to understand all kinds of diseases, and I'm a hospital, I want to augment my data from my hospital to this model, healthcare model. So that's what we do. Okay. Okay. So this is the current. Now, when we program AI a long time ago, we have to do all kinds of languages. But today we are going to use only one language, which is Python. And in data science also, okay, there's all kinds of languages, R, S, and also Python. And in engineering, there's also Python. So that's why Python is the language of all kinds of fields. That's why I'm going to teach you Python next week. Next week we are going to start coding Python. Not AI yet, but we're going to code Python. Okay. So AI, we're going to code Python. Now, even though we know Python, it was very, very difficult to program AI because very, very low level until basically Google came up with what they call a TensorFlow. TensorFlow is a library by Google. So they developed this to make it easier to develop AI neural networks using TensorFlow to make it easier. So you don't have to play with all kinds of mathematics and things like that. If you want to multiply things, you multiply things. So it's easier to use TensorFlow. Now on top of that, okay, there are other libraries. This one, it's called Keras, not Keras. Keras is another library, deep learning for humans. It is actually a high-level programming library. So remember when you want to do like this, for example, I want to create like this, right? I want to create this AI system that can understand numbers. So you have all these layers. In Python, this is how you program it. Okay. Hang on a second. So this is the programming of that architecture. So this is it. This is it. Later on, I'll explain this one in the class. So this is it. That's it. This is actually your architecture. You don't have to do low-level programming. All you have to do is change the parameters this, parameters that, parameters that, parameters that. Now, this is what we call parameters. There are other parameters. So that's why when you talk about DeepSeek, ChatGPT, or Qwen, there are millions of parameters that you can tweak. You can play with it. But there are millions of parameters. So you don't want to tweak that one because it's wasting your time. So anyway, so data set for images, there's the data set. Here's an example of ImageNet or MS Coco. If you are doing image recognition, there are data sets, and these are a data set that's provided by people. So hang on a second. Let me just, okay. Now, what I mean by data set, this is what I mean by data set. So for example, I want to, this is what they call annotating or labeling data. So I have a picture this, right? I create an area of this, and I can call this one is an area of a person. This one is also a person. Okay, and then this one is, say, for example, sofa, and so on. So this is what I call labeling. Now you have to do this to millions of images. That's why it's very, very time consuming. Very, very time consuming, and very, very, by the way, like, you have to do this millions time. So people are sharing this, and that's why I want to create like in Indonesia vocational school SMKAI, which actually created all this data set and focus in creating companies that create a data set. This is an example of a company in China then building data set. So I want to do the same thing in Indonesia to create like data set. ImageNet itself, it's an open place to contribute data sets. There are 50,000 contributors, more than 3 years. So they have like a billion of images. So this is the problem with yeah. Now today I also have my own problem. We want to have a database of
Buat ke
images
Boysik atau belum?
of license plate recognition. Sorry, not like traffic sign recognition. Traffic sign recognition. So now I am in the process of taking pictures of traffic sign. Tanda lalu lintas. Right now in taking pictures of tanda lalu lintas. It's going to take me, I don't know how many months, but I'm going to do the same thing again. Okay. Anyway, so that's the concluding remarks. Well, AI has created disruption in all kinds of industry. This is basically making inroads and everything. The question is not, people are thinking that, oh, okay, maybe it is about human versus AI. No, it's not a human versus AI, but human versus human plus AI. So this is it. So that's why you have to equip yourself with AI, because you're competing with somebody who has AI. If you're just human yourself, you don't have AI capability, then this is your competitor. So you have to know AI. Okay, just use AI properly. Okay, so this is my presentation or my class for tonight. Question, silahkan. Mashab, so that can get better. Okay, yes, Edelweiss.
Yeah, maybe this is